Hey guys, welcome back. Today Casey is going to be continuing the pipe network series and he's going to be going through profiling and designing the pipe network. So let's continue the journey and let's learn.
Welcome back everyone, this is Casey. We're going to be continuing on our Civil 3D pipe network series. In our last video we went ahead and we edited our structures in our pipes, updated our labels, and we started to insert our inverts as well as our slopes for our pipes and our structures. So between the last video and this one, I just went ahead and continued that process shown in the last video where we started from a certain point, a constraint, and then we designed with a 1% slope from our pipes all the way down. So we started from upstream and worked from downstream. Again, that's against our typical protocol, which would be to design from downstream to upstream. Every project varies. You always want to design from your constraints, but in this instance, we designed from upstream to downstream to demonstrate the relationship between negative and positive values for slopes and how that can change the way that your pipes and networks are designed. So now we're going to go ahead and we're going to generate our profiles for this pipe network. So our profiles are essentially going to be a cross section of our pipe network along the length of our horizontal alignment. So because we have three alignments that are created here, we've got our alignment for our main run, and then we've got two smaller alignments for these catch basins that kind of branch off of our main run. We're going to have three different profiles. So I'm just going to go ahead and I'm going to come back down to our little table here where we've got all of our different alignments and cross sections, and I'm just going to go ahead and table off a portion for more profiles. And I'm going to go ahead and navigate to the Home tab and then the Create Design portion of the Home tab. And then we're going to go ahead and select this profile right here in the center. And we're going to create a surface profile. So to create our profiles of our pipe networks, we're going to want to change our alignment to be the alignment of our pipe network. So we're going to start with our main run, which is Storm A. And then the surfaces that we're going to show is our EG and our PG surfaces. So we're going to show the existing grade and where it was before we did any earthwork, and then the proposed grade after all the earthwork is done and the pipes have been installed. And then we're just going to hit Draw in Profile View, and that's going to open up our Profile View creation tools here, in which we can name our profile view. I'm just going to go ahead and name it Storm A, usually name it the same as the alignment. Our view style for all of our stormwater profiles is going to be CVLX stormwater profile, and the view layer is going to remain on the 0 layer. There's no reason to put profiles on any layer other than the 0 layer. We can go ahead and hit next. Our station range and profile view height, we're going to leave both of these as automatic. And then our profile display options, typically there's nothing here to display, but I'm going to go ahead and change the labels from standard to no labels, just because the standard label set will populate a bunch of labels that we're going to change and or delete later on, and I think that it just crowds up the profile. So I usually come back and we'll add the labels that I want after we create the profile. So I just go ahead and change those guys to no labels. And then pipe pressure network, we're going to want to include our network Storm A, so we're going to select this so there's a green check mark in the box. And then we're going to include all of the pipes and structures that are along the alignment that we're making this profile. So this profile, the parent alignment of this profile is Storm A. So all of the pipes and structures in our Storm A network are along this alignment except for our pipe A4.1 and pipe A3.1, as well as our structure A3.1 and A4.1. So I can go ahead and deselect all of those so that it says no, and then I can hit next, and usually there's nothing you're ever going to change in your data bands or profile hatch options sections of your profile creation tools. And then we can go ahead and hit Create Profile View. So I'm just going to go ahead and drop this guy right there. And as you can see, it's extremely tall because we've got some sort of weird error going on with one of the structures in our profile view. But the first thing that you'll notice is that we are starting at our most downstream point on the left-hand side of our profile, and we're working upstream on the right-hand side of our profile. This is exactly what we want. This is the standard for our profiles. Everything's going to go from downstream to upstream, from left to right. You know, we read from left to right, and we go from downstream to upstream. So this is exactly what we want. And so one quick thing that I'm going to show you guys is if you ever have a scenario in which your alignment direction is wrong, which in this case it's correct. So I'm going to go ahead and I'm going to change the alignment for it to be wrong. You can select the alignment, hit this Modify tab, and hit Reverse Direction. It'll give you this little error, or not error, but warning. You just go ahead and press OK. So say you created your alignment and you didn't set the direction correctly in the first place, and it appears backwards here. You can do exactly what I just did. You navigate to your alignment, and you just click on it, and then you hit the modify drop down and hit reverse direction, press OK through this warning, and then it'll reverse the direction of your profile to be the correct direction. Okay, so that's how you're going to fix profiles that are reading from upstream to downstream, which is incorrect. We want it the profile to be downstream to upstream, so the downstream most point on the left, upstream most point on the right. So what you'll notice here is you'll notice a couple of different things. We've got one profile here, and this is going to be the profile of our EG surface. You can see the data source here is EG, so this is our existing grade surface here. And then this profile here is the profile for our PG surface. So this surface is generated based off our conceptual grading plan. So we've got some weird funny gaps going on here in the profile where it seems that the elevation drops extremely low. So that's something that's going to have to get fixed within the surface itself. But then you also notice that we have our structures and pipes, which are obviously floating outside of the profile. So in our last video where we set the inverts for our structures and our pipes, we just went ahead and set it at the top and then designed 1% slope in all of our pipes and just ran downstream like that. We didn't take the time to look at the elevations of the proposed grade and see, does this make sense? And the reason why we didn't do that is because it's much easier to do that once you have your profile view to look and see how much cover you have. So obviously when we generate this profile here, we can see that we have structures and pipes floating out of the ground, which is not correct, not common practice. Pipes and structures can't float out of the ground. Obviously they're going to be underground. So now we know that we're going to have to go and change and edit some of our inverts. So typically, what I usually prefer to do is do exactly what we just did. I'll just punch in an elevation at one point on the pipe that seems to make sense, run it at 1% from there, and then I'll generate my profiles and then continue to iteratively design based off of the constraints, one of the primary constraints being enough cover. So there are going to be areas where we're not going to have enough cover. So just following our proposed grade here, so we're just going to go ahead and select our proposed grade surface. Following our proposed grade here, we're probably going to see these structures here, and then this pipe is not going to be able to run at 1%. The road here is much steeper than 1%, so this pipe is probably going to have to run at closer to 10%, and it's going to run down to 10%, and then this structure will be down here. So in order for us to just get a little bit clearer of a picture of what's going on here, we can go ahead and add labels to our profile view so that we know which structure is which pipe is which, and then we can go back to plan view and edit those structures and pipes. So I'm going to go ahead and select one of our pipes, and I'm going to hit add labels here in the top left, and I'm going to hit entire network profile. And this is going to populate all of the labels for every pipe and every structure within the profile. And again, the select similar command works on these structure labels, and these are actually labels that exist. They're structure profile labels and pipe profile labels. So if I select a pipe profile label, do select similar, it'll grab all the other pipe profile labels, including pipe profile labels in other profiles. We don't have any other profiles, so it's only grabbing these here. But it's not going to grab any of the labels that we made, the pipe labels that are in our plan view, which is good, because you don't want to accidentally change the style in plan view when you're only intending to change the style on your profiles in your profile view. So we can go ahead and change the style. Typically, we're going to put the style as just the style pipe. So I'm going to change it from standard to pipe. And we might end up adding one of these offset styles. Typically, if we have a pipe larger than 18 inches in diameter, the pipe will be bigger, and then it'll kind of cross through this label style. And we can fix that by changing the style from pipe to pipe offset, in which it'll offset the label further away from the pipe. So that 0.17 is less offset, so that's for pipes that are smaller. And then all the rest of them, 0.27, 0.32, and so on, those are for pipes that are bigger, so that the label just sits on the pipe and is much neater, much nicer to look at. So we're going to go in and we're going to set that label style, and then for our structures, we're going to do the same thing. We're going to grab the structure, we're going to run select similar, and it's going to grab all the other structure profile labels, which we can then change the style of to be CVLX PR Storm Profile, or we could change it to just CVLX PR Storm. We're going to change that to CVLX PR Storm for now. And the same thing, we're going to drag them off to the side just so that they're not cluttering all over the structures. You always want your structure profiles to be leaders. It just looks nicer, it's neater. So we're just going to go ahead and change these, drag them all off to the side. And then this guy, this structure did not seem to produce a label. There's a label. It's just an extremely tall structure. So this is an issue that you're going to run into extremely commonly, where you have structures that, for whatever reason, the sump is the term that we use for essentially that area between the lowest invert entering in that structure and then that area below that can kind of hold water or sewage in the case of storm sewer pipes, is extremely low. So in order to fix that, we can just go ahead and identify this pipe. So this is pipe A7, right? So we can click on this guy and we can click Structure Properties. And we're going to pull up the Structure Properties and we're going to go to Part Properties. So if you go to Sump Behavior, this is going to control the behavior of the sump, right? So we have our sump behavior or our sump depth or elevation defined by depth, in which the depth is set at 0. But sometimes you run into this error with Civil 3D pipes. A lot of things in CAD and Civil 3D can be kind of quirky. We're going to change this guy to elevation, and then you're going to see that it's going to put the sump elevation at 885. We're going to change it back to depth, and then the depth at 0, the sump elevation should be at 885. We hit apply, and then as you can see, it's going to pull that guy all the way up to where it should be. Now it's correct. And then the last thing, or the last reason why this profile is extraordinarily tall, is just because of these weird spots in this PG grade in which the elevation seems to be all the way down in the 500s. So I'm not exactly sure what's going on there. We could troubleshoot the surface later on, but I'm going to choose not to burn too much time doing that. So we're just going to go ahead and drag this profile back up here. So now we've got labels on all of our profiles, and you can follow that process on all of your profiles to create labels and create the correct type of labels. And they're going to want to do the same thing that we did on our plan view, and you're going to want to make sure that the style is coordinating well with the type of structure. So pretty much all of our structures here are catch basins, and if you remember, our label styles on our plan view for catch basins are CVLX PR Storm catch basin. And that's the case for every single structure in this network besides the outfall at the bottom. So we're just going to go ahead and we're going to make all of these labels for all the structure labels besides the outfall at the bottom. We're going to make them the exact same style so that instead of saying rim, they say top, which is a more appropriate term for the elevation of a catch basin. So we're just going to go ahead and change these from CVLX PR Storm to CVLX PR Storm catch basin. And then this guy is our outlet, so we're just going to change it to CVLX PR Storm head wall. It's not a head wall, but head walls are typically outlets. That's a more appropriate label style for the outlet there. And then we can drag some of these pipe labels on these shorter pipes so that they're a little bit cleaner. Same with this guy up here. Okay, now we still have the issue of floating pipes. So how can we fix this? Well, you'll see that this pipe here, if we select pipe and pipe properties, we can essentially design and change our structures and pipes just from here in profile view. So obviously with this pipe running at 1%, it's going to start floating out of the ground right about this point, and pipes don't float out of the ground. So we're just going to increase from the end, which is the upstream, so the hold end. So we're going to change our pipe slope hold end to about 10% versus 1%. Hit apply, and as you'll see here, it's under our PG surface now. But this PG surface is running a little bit less than 10%. So now, right here, so this is our PG surface right here. Now we have a pretty deep structure here. So each one of these intervals being 1 foot, or 1, 2, 3, 4, 5, 6, 7, 8. Yep, 1 foot. So each one of these dashed pink lines being 1 foot. We've got the crown of the pipe is about 1, 2, 3, 4, 5, 6, 7 to 8 feet below the ground, which is pretty deep. That's not really necessary, so we might can decrease the slope of this pipe just a little bit more. So we'll come back to this guy. We'll change it to maybe 8%. That's probably not enough. We'll go to 9. And that looks about good. That's about following the exact grade of the road here. So we've got about 3 feet of cover all along the road, which is perfect. So now we can go ahead and we can select this structure, and we can follow the same process that we followed in plan view, but do it in profile view. So we can grab the structure, hit connections, and we can select pipe A5 and pipe A6, hit match inverts, and we can match to pipe A6, which we just edited. So now the lower end of pipe A6 has an invert of 863. So we'll go ahead and hit OK, hit apply, OK. And as you can see, this pipe, its connection to A5 just went down and matched to this invert here. And now we can continue the process that we did all the way before, where we go structure to pipe, structure to pipe, structure to pipe, and simply set our slopes to what they should be. So we've got a pretty flat area here, so this guy can be about 1%, and then our 860 is going to be at the end point. So we're going to hold end, and we're going to set -1% because, again, we're designing from upstream to downstream, which, again, typically we're going to design downstream to upstream, but we're just designing from our constraints here. So we've got pipes floating out of the ground. We've got a super steep slope here, so we're probably going to be more stressed on cover in this center area as well as these areas with steeper slopes. We can do the exact same thing from downstream to upstream, which is probably what you're going to do, right? So what's an appropriate elevation for our pipe to outfall into our pond, right? So we've got all these elevations here in the pond. The pipe might be halfway up the wall at 830. So our elevation here, or our invert here at the outfall, might be 830 versus 859. So we can go ahead and we can navigate to that structure, which isn't showing up in our plan view due to the type of structure. So we'll just go to it, or in our profile view, so we'll just go to it on our plan view. We'll hit structure properties, and then we're just going to go ahead and change, or excuse me, we have to do this at the pipe. So the start elevation at this pipe, instead of being 859, should be about 830. Okay, and then we're going to go back to our profile view, and you can see how it changed. So now it's under the ground here, and that's pretty deep. So we might go ahead and edit that from 830 to maybe 830, 832 or 834, something like that. So we're just going to go ahead and find our start invert elevation, maybe change it to 834, see where that puts it. This is our proposed grade right here, so we still got about 3 feet of cover, so that's pretty good. And then we can do the exact same thing, except now we're designing from downstream to upstream. So we're going to, instead of holding our end invert, we're going to hold our start invert, and instead of going -1%, we're going to go at 1%. Hit apply, okay? And as you can see, the depth of the structures is just automatically updating to accommodate the change in the inverts of the pipes. So we can just continue to do the same thing. We're going to grab this structure. We're going to go to connections. We're going to select both of these connections of the pipes, and we're going to match them to the one that we just set to that lower elevation, which is A1. Press OK, apply, OK, right? And then it's going to go ahead and update. And then this pipe, we're going to select this pipe properties, and we're going to change our pipe slope, holding the start invert elevation, and we're going to change it from this really high 93% back to 1%. And as you can see, it's going to update, and that's much more appropriate. The slope here for the PG is it's flat in here, but it's going to increase drastically in here. So this long pipe right here is probably going to be at a much steeper slope. But as you can see on our proposed grade surface here, so I'm just going to go ahead and grab our proposed grade, we've got a really, really steep portion that these pipes are running through, and then it flattens out very, very sharply. So we might, at some point, have to add a structure right here so that we can transition from that extremely steep slope to that more shallow slope, or this structure here will have to get very, very deep so that we can take this pipe all the way into the bottom of the structure without having to add in that middle structure. But it looks like adding in that middle structure is going to be the most appropriate solution, and I'm going to show you why we're going to have to do something like that. So if I go ahead and grab this structure, and I match pipe A2, A3, we're going to match it to pipe A2. Okay, apply, okay. As you can see, this is our PG here. This is this guy. And the pipe is sticking out of the ground, which is something you're going to run into very, very commonly. So you've got this pipe sticking out of the ground. That's no good. That's no bueno, right? So we're going to have to, again, edit these pipes in order for the pipes not to stick out of the ground. So if we zoom out and get a better picture of what's going on, this invert here is going to drop much, much lower so that it's going to be able to sort of tie in from this lower point into this structure without sticking out of the ground. So we probably won't have to add this structure here in the middle. So we're just going to go ahead and we're going to continue to edit our structures and pipes. So we'll go back to the upstream point, right? Because now what we have to do, kind of our goal here to keep the pipes from coming out of the ground, is we need to lower this invert here. So we'll just start with that. So this pipe, we've already got our start elevation set pretty low at 834, and then we can run that guy at 1%, so we're just going to change our pipe slope holding the start. And now you can see that this structure is super, super, super deep, and now we have a ton of cover here. So we're going to increase the slope of this pipe so that it still remains under the ground. However, we're going to increase it essentially as much as we can so that structure isn't super, super deep. So 5% we can get away with. It looks like we might be able to get away with 6%, so we'll go ahead and change it to 6%, and that looks fine to me, right? So now we have this structure, which is coming up to still sticking out of the ground, right, because this invert is far too high. So we're going to go ahead and lower this invert. So pipe properties, we'll just match it to this guy. Structure properties, we're going to go ahead and select A3, A4, and A3.1, and we're going to match it to A3. So you cannot see pipe A3.1 on this profile because it's not showing in this profile view, and because that pipe does not run along the alignment that's the parent alignment of this profile view. However, we're still going to change that invert from the connections tab of this structure just because that invert was also far, far, far too high. So that's why I went ahead and did that. Right, and then same deal here. We're going to select this structure, structure properties, grab our connections, and same thing that I just explained. You cannot see pipe A4.1, but its elevation or its invert elevation is far, far, far too high. So we're just going to go ahead and match that. Also to pipe, not pipe A4, match inverts to pipe A5. So we're going to close that out. We're going to have to Control Z to go back. Structure properties, and then we're going to match to pipe A5. All right, cool. So now all of our pipes and structures are underground as they should be. You can see that this is our proposed grade here. And one of the things you'll notice is that we haven't changed anything in our structure properties besides matching inverts. But we haven't changed any of the properties about the actual structures. However, they still all have their tops right here at the PG. Why is that? That's because each one of the structures and pipes, but the structures more importantly, have a reference surface. So the reference surface here is PG. We have a really key feature here and really key setting, which is the insertion rim behavior of the structure. And it has this value here, automatic surface adjustment, set to true. What that does is it goes ahead and it sets the rim or the top of every structure to whatever the elevation of the surface is at the point of the structure. If you change this to false, you can set the elevation of the rim of the structure to be whatever it is that you want it to be, but we typically leave this on true, and it's just going to go ahead and it's going to punch in your rim and your tops and your throats of all your different structures for you, so that you don't have to go do it. And then obviously the structure labels reference the properties of the structures, and those go ahead and update for you. So that kind of saves you a ton of work. There are some instances in which you might want to change that value. So again, I'll navigate to it one more time. You might want to change that value from true, this automatic surface adjustment, from true to false to set a very specific throat, rim, top elevation or grate elevation, depending on specific circumstances. Or you could simply make your surface much more accurate so that your surface is the elevation that you want the structure to be at that point. So we'll touch more on that later on or in a later video. But this is a very, 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 very key setting, and that's why you'll notice when we're making all these changes, the structures are automatically updating such that their tops are along this PG surface, right? Because they all reference the PG surface, okay? So that's a super key, important feature, right? So just going ahead and looking around, there are a couple spots that are jumping out at me. One is this point here, again, where we transition from a really steep slope to a much more shallow slope, right? So scenarios where you transition between two different slopes very sharply are points in which you might be restricted for cover, right? So this is a spot in which we might use as a constraint to design our pipes. So because we have enough cover here now, we still have to keep an eye on it. So if we change the slope of this pipe or the inverts of either one of these pipes, we might be much tighter on cover here. Okay, and then up here in this area where we have this kind of huge mound, right, we have a ton of cover and a really, really deep structure, right? So that's not entirely necessary. So what we can do is we can adjust the invert of this pipe here such that it comes into this structure at a higher elevation, right? So the water is going to flow in, it's going to hit the edge of the structure, and it's going to drop all the way down to the bottom of the structure where it's going to exit in the downstream pipe. So the structure is going to remain very, very deep. However, this pipe won't be quite as deep, so they won't have to dig a super, super deep trench to entrench it, right? So you need to always be thinking about how deep are your pipes and structures, right, so that it can be easy to install. Because we have this 221-foot pipe here, that runs under an area which has such a sharp change in slope, we have to be really careful about having enough cover in this area, right? So this end of the pipe, as you can see, has north of 10 feet of cover. However, here in the center of the pipe, where we have that sharp grade change, we only have just a few feet of cover, just 3 feet of cover, which is our minimum cover. Your cover might be different, or your minimum cover might be different in other circumstances, but that's the design specification that I've put into place just for the sake of this demonstration. So now we can go ahead and change this pipe. And we can change it from its upstream point, which is going to be the end point, and instead of it being at just under 7%, we can maybe set it to right at 4%. And again, it's going to enter in here, right? We could probably get away with a little bit more, maybe 1%. Nope, so that's not going to be steep enough. So we'll go to 3%, and that's much better. And then this guy here, we're just going to go ahead and do structure properties, and then the automatic surface adjustment should be set to true. So we're just going to go ahead and reset that to true, hit apply, and then it's just going to automatically update again sometimes when it gets wonky like that. Right, so now this pipe here, instead of it being all the way down here and being almost 20 feet deep, so an almost 20 feet deep trench at that end point here, it's still quite deep here. They're probably going to have to dig just about a 10 foot deep trench, or the trench for this pipe is going to be about 10 feet deep right here in the center, but it's much shallower on the ends, right? So that's going to save money later on. And so as you can see, the profile is extremely useful for identifying points where you might have trouble meeting cover requirements, or identifying whether or not you have enough fall from your upstream point to your downstream point for that specific run of pipe. And it's extremely useful to use your profiles in your design process rather than doing a bunch of calculations by hand or eyeballing based off of your proposed grade, whether or not you have enough cover, and punching in your inverts manually yourself for each and every pipe. You can use these tools in Civil 3D, changing the slopes of the pipes by holding one end, changing the inverts, matching the inverts that tie into one structure to one another to speed up the process of assigning inverts to your pipes and structures tenfold. We've essentially just designed a run of pipes and structures which meet our cover requirement. We've minimized the depth of trenches to save money and the depth of structures to save money. And now they're all set to appropriate inverts, appropriate slopes, and they're pretty much ready to go. And then our profile is almost completely set up, besides this strange error in the proposed grade surface, which is something that we can troubleshoot later on. But our profile is almost entirely set up to be plotted on a profile sheet and then submitted to the stormwater division of any jurisdiction for their review. Most jurisdictions are going to require you to submit profiles. So now this is already done. So we've used it as both a design tool, and we've also the output of that is also something that we're going to have to submit anyway. So we've killed two birds with one stone by using our profile to help us design our pipe network.